All right, guys. So we just did the gathering data part of this section. Now we're going to focus on the organization part. And we organize our data after it is collected. And we want to use sampling techniques to have a best representation of our population within our sample. Had like a brain fart for a second, so I apologize. Now, when data is in its original form, we call that raw data. Raw data is the best kind of data we can work with. The reason why it is the best kind of data that we choose to work with is because we can objectively determine what our values are and what those values represent. This is the least aggregated data. As you will learn in research methods, the more aggregated the data is, it decreases the reliability of what you're interpreting, which means the internal validity will not hold up. A frequency distribution is the organization of raw data in the form of a table, using classes and frequencies. Each raw data value is placed into a quantitative or qualitative category called a class. The class is the rows of our frequency distribution. The frequency of a class is then the number of data values contained in the specific class. So, for example 6 and 7, we're going to go over on how to create a categorical frequency distribution, and then we're going to create what is called a grouped frequency distribution. Now, number 6 says, there were 21 participants in a study on personality traits. After being shown 5 images, 1, 2, 3, 4, and 5, each participant selected the one they were most appealing to, which one was most appealing to them, excuse me. A, the images of the participants selected appears below. Complete the frequency distribution for the data. So you want to create a table. Now, let's start off a table with 2 columns. I'm going to call this image here. And I'm going to put frequency here. There are 5 different images. 1, 2, 3, 4, and 5. And I like to put a total in my last row. Now, using this graphic right here, how many participants find picture 1 the most appealing to them? The answer is 5. 1, 2, 3, 4, 5. 5 participants, which means my frequency will be 5. Do the same thing. We want to find the frequency for picture 2. How many participants found picture 2 to be appealing to them? 1, 2, 3, and 4. Continue the same process for 3, 4, and 5. And you will see that 3 participants find image 3 appealing. 1, 2, and 3. While I believe 5 participants find picture 4 appealing. 3, 4, and 5. And if you notice, 4 participants found image 5 appealing. Let's add up our frequencies. 5 plus 4 is 9. 9 plus 3 is 12. Plus 5 again is 17, excuse me. Plus 4 is 21. And remember, there are 21 participants. So we add up our frequency to what is called the total frequency to make sure that we constructed our frequency distribution correctly. And that is how we create a frequency distribution. Now, B says, based on these images are associated with 4 personality traits, but not every image is associated with every trait. The table below shows the trait and images and the image associated with them. So we have traits, which is optimistic, indecisive, analytic, and impulsive. And the images right there represents each. Based on this information, how many participants selected an image associated with being indecisive? Indecisive is image 3 and 5. So if I go back up to my frequency distribution, 3 participants for image 3, 4 participants for image 5. That means for indecisive, that will be 7 participants in total. And that is the answer to number 6. So guys, hope that made sense. I hope you really enjoyed this question and understood how to complete it. Let's zoom out more so we can see everything that's going on. And if you understand it, that is great, because now we're going to move on to number 7, which is a little bit more challenging than number 6, because number 7 will be based on quantitative data, numbers. So that means there are some more approaches that we have to take. Let's make some more room first. Okay. Number 7 says, here are the test scores for a math test. Construct a group frequency distribution for the data. In the distribution, the frequency of a class is the number of exams in that class. Note that we are using a class width of 4. I want to just underline that for a second, and we will apply that later, and we'll see how it applies when we create our frequency distribution. So once again, let's have 2 columns. I'm going to call the first column test scores, or just scores. And the second one will be frequency. Okay. Now, this is numerical data, so we have to respect the fact that an order should follow. Identify the smallest data value for me. The smallest data value in my frequency distribution, well, in my table, will be 75. And somebody identified to me the largest. The largest data value is 90. Okay. Now, we're going to start off on the smallest data value, and we should end on either the largest data value or a value that is larger than the largest data value. And I'm going to explain how that works. Start with 75 for our first class. Now, we're creating a grouped frequency distribution, which means our classes must create groups of data. And then I'm going to now highlight the note that we was given, because the note says that we are using a class width of 4. The width is the distance between each class. Is distance between each class. So, between class 1 and class 2, in terms of the first value, the distance between the first value of the first class And the first value of the second class will be a distance of 4. So to find the value for my second class, we are going to add 4 to 75. So 75 plus 4 is going to be 79. And let's do it again. Let's add 4 again to 79. 79 plus 4, that's going to be 83. Let's add 4 one more time. That's 87. But if you notice here, if we decide to add 4 again, keep my color consistent. If we added 4 again, 87 plus 4 is 91. And if you notice, the highest data value, the largest data value in this data set is 90, which means we need to get rid of this class. We don't need that value there. It's going to go over the highest limit, the highest value, I should say, excuse me. So I'm going to call my last column, messing up all my words, my last row, my total row. So I'm just going to rescale my table. Now you're asking yourself, what about the other values like 76, 77, 78? Where do they go? Well, this is how we find the values. Let's look at the values 75 and 79. The first class starts at 75. The second class starts at 79. We have the starting points. What about the ending points? Well, if the second class starts at 79, that means the first class must end at 78. If the third class starts at 83, that means the second class must end at 82. If the fourth class starts at 87, that means the third class must end at 86. And to find the last value, we are going to respect the width. Because remember, the width is 4. So 78 plus 4 is 82. 82 plus 4 is 86. 86 plus 4 is going to be 90. And the values that you see here in red, we call those the upper limits. The values that are in black for the scores, we call those the lower limits of a frequency distribution, of a grouped frequency distribution, I should say. Now, let's complete this. What test scores are in the class from 75 to 78? Well, that's going to be 75, of course, which is 1. 75 again, 2. 76, 3. 77, that's 4, which means my frequency is 4. 4 test scores are in the interval of 75 to 78. From 79 to 82, that is going to be 1, 2, 3, and 4. 83 to 86. 1, 2, 3, 4, and 5. 87 to 90. 1, 2, and 3. When we add the frequencies together, we have 16. And if you count how many data values that are in this data set, that is also 16. This right here is our grouped frequency distribution. All right, guys, that is the end to this video. I know it ran for about 15 minutes. Sorry it went so long, but hope you guys understand it. Hope it makes sense to you guys, and I'll see you soon. Take care.